In another video on logarithms, we were introduced to decibels, abbreviated dB. And in this video, we will explore more with decibels in the realm of sound recording and home stereos. When sounds are recorded, there is a mixing step where all of the sound sources are added together to make one final sound. The word mixing means exactly what we think it means: combine things together through addition. Addition is a simple arithmetic operation. Start with one quantity, add another quantity, and now you have more. To understand how addition is involved with sound recordings, let's start with a simple experience we may have encountered. Imagine you are in a crowded movie theater for two movies. In the first movie, only one person really loved it, and so he claps at the end. But in the second movie, everyone really loved it, and they all clap at the end. Which movie had louder applause? What this means with audio recordings is, the more instruments that are mixed together, the louder the sound will be. For the next example, we're going to make our own experiment with adding copies of the same sound. Using recording software, I can copy the same note from a synthesizer to multiple tracks. I'll start by playing one. And next, I will unmute a second. We hear a definite change in volume. Now if I unmute a third track, there is a change in volume, but it doesn't seem to be as drastic as the one from 1 to 2 tracks. The reason for this is related to the logarithmic nature of how the human ear works and to decibels. For this experiment so far, we can think of decibels as a logarithmic unit used to describe the ratio between two signals. On audio mixers and home stereos, the level 0 dB is set as a threshold. If we push the volume above 0 dB, then distortion will occur. Thus, we need to set the dB level for sound sources to be below 0, using negative decibels. Some home stereos, in fact, use negative decibels to indicate volume level. Let's return to our example with our copies of the synthesizer track, where I have all of them set to the same output level. I'll start with just one track playing again, and this time our focus will be on the stereo output meter, which measures the final output. The number one track is playing is negative 14.4 dB. When I unmute a second track, the number changes to negative 8.3 dB, which is an increase of about 6 decibels. If I unmute a third track, the output number doesn't increase by 6 decibels, but if I unmute a fourth, the stereo output meter reads negative 2.3 dB, which is another 6 decibels above where we were with just 2 tracks playing. The summary of the experiment we just observed is this. If we double the amplitude in sound source, then we get an increase of 6 decibels in our stereo output meter. The word amplitude refers to the voltage measuring the sound pressure levels of our sound sources, which we can see in the oscilloscope. If I add two of the same waves we were listening to, then the height of the waveform on the oscilloscope increases by a factor of 2. The formula for calculating the ratio of voltages between the signal with one wave playing and the signal with two waves playing is dB equal to 20 log of V2 divided by V1. When we played two tracks at once, the voltage, or sound power, was twice as much as when we played just one track, so the change in decibels that we observed can be verified. dB equal to 20 log of V2 divided by V1, which is 20 log of 2V1 divided by V1, which is 20 log 2, which is approximately 6 decibels. Now let's look at another scenario. We're done mixing our sound sources to a completed song, and we want to play that song on our home stereo. You like the sound, but you want to hear it twice as loud. We're going to investigate what it means to make something twice as loud when using decibels in this situation. One thing we could think to do is to add more speakers. This is in line with our examples. More of the same sound makes it louder. You can experiment with this by unplugging a speaker from your home stereo and comparing that with both speakers plugged in. But another thing to consider is where we personally are standing in the room. If we get closer to the speakers, it does get louder. So, does adding another speaker really double the volume? It does get louder, but there will be different opinions about it being twice as loud. Okay, so what if we increase the power that our amplifier puts out? We could take our 100-watt amplifier and exchange it for a 200-watt amplifier. But this also does not make it twice as loud. What is interesting about these experiments is that having 2 speakers instead of 1, or doubling the power on our amplifier, only increases the decibel level by 3. The reason why comes from the formula for calculating the ratio of power. The result is dB equal to 10 log of P2 divided by P1, which is 10 log of 2P1 divided by P1, which is 10 log 2, which is approximately 3 decibels. If we use our volume knob and increase by 3 decibels, we achieve the same effect as adding a second speaker or doubling the amplifier power. Furthermore, if we increase the setting by the volume knob by 6 dB, considering our previous experiments, that still may not sound twice as loud. A general consensus from the study of psychoacoustics is that an increase of 10 decibels makes the sound twice as loud to our ears. The important thing for us to take away from these experiments is that decibels is a ratio between 2 signals and not a unit of measurement. While we can add 4 apples to 4 apples and have twice as many apples, if we add 2 signals with the same decibel reading, it does not double the sound power, pressure, or intensity of the signal.